of discontinuity. So what we've done so far is we did ones that were like this. These ones up here. So we had ones that were transformed form. And if they were in transformed form, your vertical asymptote, no matter what, came from your non-permissible values. And if they were in transformed form, your horizontal asymptote, which was these ones, transformed form, this would be a +0 at the back, right? So this would have had y equals 0 to be y equals -6. And then these ones aren't in transformed form, so we have to use the rules. If the numerator was smaller than the denominator degree, you got y equals 0. If the numerator was the same as the denominator degree, you got y equals the leading coefficient. Right? We did that. That was the rules we had.
I wasn't here Friday. Can I get the sheet?
So you watched the podcast? Yeah. All right. Now, what happens if we get factors when we factor that cancel off? So here it says points of discontinuity is a coordinate on the graph of a function that is not continuous or a hole in the graph. So this one here has an open hole in the graph at 3 and 1. It occurs when the numerator and denominator of a rational function are simplified by dividing out the common factors. So if you look here, we have x squared minus 5x plus 6 over x minus 3. When I factor that to the numerator, I get x minus 2, x minus 3 over x minus 3, and these x minus 3's cancel. You see that? When that happens, you don't get an asymptote, you actually get a hole in the graph, like an open circle. So how do we find out where that open circle is? Well, we know it's at x equals 3, because that would be the non-permissible value, right? How do I get the y? I just plug it into the simplified form. So after I canceled it off, I was left with f of x equals x minus 2. So I do f of 3 equals 3 minus 2, f of 3 equals 1, so I know my open dot's at 3, 1. I just plug it into the reduced equation. That is an actual standard of excellence. If I ask you for a y value at the point of discontinuity, that is a standard of excellence. The easiest standard of excellence out there. So I always pray for it. I'm like, please put this question on the test. This is a great standard of excellence. All I have to remember to do is plug the 3 into the reduced equation. People still don't remember that and get it wrong, but that's on you. Because this is a nice standard of excellence. It's not a real hard one. Okay? So I go over here and I put the 3, 1. It's my open dot. Boom, boom, boom. Okay? How do I get to draw the rest? Well, the actual graph itself is what's left over. So once you canceled it off, I was left with y equals x minus 2, right? So I draw an open dot at 3, 1, and then I sketch that graph. So what do? I go, if I want to sketch f of x equals x minus 2, this is grade 10 again. I've never gone, I don't think, to a day where I haven't said grade 10 at least once or twice. Yes? So here's my y-intercept. It's at -2. So I go to -2 and I put a dot. And then I use my slope, which is 1 over 1. So it's up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. Don't close that. Up 1, right 1, up 1, right 1, up 1, right 1. How do I go the opposite direction? Why is it down 1, left 1? Why is it the opposite? Why can I do that?
Because they got 2 arrows.
It's the backwards side.
No, none of those are the real reasons.
The inverse.
Nope. If I want to go left and down, up and right is +1 over +1, right? Correct? Could I, if I want to go down and left, then I would have to have negative and negative, yes? What happens when I have a negative and a negative? Makes it positive. So that's why you go the opposite direction, because this could have been negatives that canceled off. That's why. None of you seem to know that, but you knew you could do it. That's okay. But now can you take in why you can go the opposite? So say your slope instead was 1/3, negative 1/3. Let's pretend. So I know I can go down 1, right 3. We agree? But we can go the complete opposite. This is totally side note, nothing to do with this question. So I can go down 1, right 3. Well, your teacher also told you that you could go up 1, left 3. But why? Where could the negative gone? On the bottom, couldn't it? Is that not the same fraction, technically? Negative 1/3 or 1 over -3? Are those not the same thing? Yeah? Would this now be up 1, left 3?
Yep.
That's why you could do the opposite. That is why. Negative a negative, or the negative can move. That is why. Does that make sense? We don't say just is. We always ask why. You should always ask your teacher why. Because this, well, why? You should always understand why. Then you won't make oopsies. Okay? So we understand why. It's really hard for you guys to understand it because we're trying to teach you slope to begin with. You now know slope. So when I say that, you're like, oh, that's easy. Your teacher probably said it and you were like, I have no idea what you're doing right there, sir. All right. So down one, left one, down one, left one, down one, left one, and we can go the complete opposite, connect it, and make this line. We agree?
Yep.
So when we go to draw out a rational graph in general, what we have to make sure we do is factor both the top and the bottom. See if something cancels off. If it does, I have a point of discontinuity. If it doesn't, I just have asymptotes. Okay? Now this one, when it canceled off, was there any factors left in the bottom? Was there anything down here? No, so that means I don't have any asymptotes. If the total denominator cancels off, I'm just left with a line with an open dot. If the denominator doesn't cancel off, I'm left with an open dot and asymptotes. I'll have both. Now, if I don't have a vertical asymptote, if there's nothing left on the bottom, I won't have a horizontal. Therefore, they go hand in hand. If you have one, you have the other. If you don't have one, you don't have the other. So let's look at some examples. So we're going to go down here. Steps to determine coordinates of the point of discontinuity algebraically. You factor the rational expression. You simplify the rational expression by canceling out factors. You substitute the MPV of x into the simplified form and solve for y. So what we're going to do first is we're going to factor this. So we're going to go down here and we're going to factor this. So when I factor the top, what do I get? X and x plus 5 is a GCF, greatest common factor. The bottom, but multiplies to give me 10 and adds to give me 7. I don't have to do decomposition one at a time. What's it going to be? X plus 2, x plus 5. Oh my goodness, something's canceling.
Oh. Wait, you think I'm an excellent?
Yeah, I'm all over it. The x plus 5 canceled off. What x correlates with x plus 5? X equals? Negative 5. I just found the x of my point of discontinuity, didn't I?
Sorry.
Okay. What's left over is my new equation, which is x over x plus 2. So that's what I'm going to end up graphing with an open dot at negative 5 and some. Right? So the graph I'm going to draw is actually going to be a rational graph, one of those curvy graphs that we drew before, with an open dot now. Something canceled off. I need to figure out what that open dot is at. How do I get the y? You started that in, you put that line in the, you put the 5 in the equation and you mix it all. Okay, so you plug the negative 5 into the reduced equation. If you plug it into your original, which you were completely correct, if you plug it into your original though, you'll get 0 over 0, which isn't going to work, and you're going to get mad at me and you're going to call me over. You'll be like, Mrs. Love, something's wrong. You're doing it wrong. That's what's wrong. You plug it into the reduced one. So we plug it into here. So we have x equals negative 5, and we get y equals negative 5 over negative 5 plus 2, which gets us negative 5 over negative 3, which gets us 5 over 3. Do we agree? So there is an open dot there.
Oh, I just messed with that.
So there's an open dot there, yes? So when I find it out, I immediately go and draw it. Because a lot of people will forget to put it onto the graph. Because your calculator, when it draws it, it doesn't really draw an open dot. You don't really see it. It just shows it on the table of values that it doesn't exist, but your graph looks like it's solid through it. So I'm going to go to the bottom, and I'm going to go y scale 1, and I'm going to go x scale 1. So whoever's marking this knows where my brain was at, because they don't know unless you tell them. So I need to draw a dot at negative 5 and 1.6. 1, 2, 3, 4, 5, 1.6. One of these, there we go. Negative 5 and 1.6 have an open dot. We agree? aka point of discontinuity. AKA graph is discontinuous there. AKA open dot. AKA no points. AKA don't put in your domain array. Right?
Yes, sir.
All right. We now have this equation left over. Does this equation produce asymptotes?
Probably.
I still have a non-permissible value that I didn't deal with. I dealt with the one that was x equals -5. Yes? I haven't dealt with the other one. What can't my other x be? That would make my denominator be 0. X equals -2. Can't be that, so what is it?
So, NPV.
Rhymes with,
NPV. What is it?
rhymes with asymptote.
What?
Ah, it's an asymptote. It's a vertical asymptote. I don't know why I wrote vertical like that. So the NPV that doesn't cross off with the numerator is an asymptote. So on Friday when we did this, we actually sometimes had two asymptotes. Like here. This one here, when we factored it, we actually got two factors in the bottom. We got two vertical asymptotes because nothing canceled off. Right? This was an asymptote, didn't cancel. This was a vertical asymptote, didn't cancel. So was this, and so was that, didn't cancel. Right? So your NPV that doesn't cancel off is vertical asymptote. So if we go back to this one, we have a vertical asymptote at x equals, I don't remember, -2. And then we go down to our graph, and we go to -2, and we go, not here. And how we show not here is a dashed line that says you can't go through it. We agree? If I have a vertical asymptote, I have a horizontal. They go hand in hand. If I have one, I have the other. No matter what. So, the degree of my numerator is 1. The degree of my denominator is 1. So when that happens, I take their leading coefficients to get my horizontal asymptote. So what's in front of each of them? A 1 and a 1. What's 1 divided by 1? 1. So I have a horizontal asymptote. At y equals 1. So I go to where y equals 1 and I say not here. And I draw those first. How do I get the rest of the graph? Calculator. Plug the original into your calculator. And when I plug the original in, I will plug it in not as a fraction, because the moment you plug it in as a fraction, you get fraction answers in your table of values. So I would plug it in as numerator in brackets divided by denominator in brackets. Everyone's typing it in. Grab your calculator. Sound like Dory. She's talking to the whales. She's like, I speak whale. I love Dory. Such a happy little fish. Okay, once we've typed it in, we go to our table of values, and our table of values gives us coordinates, and we do not wing this, we do not send this, we do not do any of that. We are geniuses, and we type it in properly. So, this starts at -11 on my x, and -11 is at 1.2. So, look at me go. 1.2. Then -10 is at 1.25, so very similar. Then -9 is at 1.28, still very similar. Then -8 is at 1.3. -7 is at 1.4. -6 at 1.5. -5 is an error. Woohoo! It should be. It's a point of discontinuity. -4 is at 2. -3 is at 3. -2 is at error. Okay, so I'm just going to wing it and send it up there.
Yes.
Upward. No! we are getting full marks on our diploma. We're not getting part marks. We're not going to be like, who's this teacher who taught this kid to wing it? No teacher does that, actually. We all know that you guys just don't follow what we say. So it's just that. So I need between -3 and -2. So I go second trace value, and I put in -2.5. Because I'm not sending it. I'm not letting anyone take off marks on my diploma. No, I'm not. -2.5 is at 5. 1, 2, 3, 4, 5. And then I'm going to go -2.25. Second trace value, -2.25. And I'm like, you try and take away marks from me. 6, 7, 8, 9. You're not going to be able to, because I did not go lazy. I am amazing. So I'm going to connect. I am not going to draw the line through the point of discontinuity, because then that would say it exists, and it doesn't. That's where there's a hole. And then I draw through, draw up, and I put an arrow, and then I put an arrow, and the graph keeps going. What?
What's stopping us at -3 to just draw a little line and then, like, just so that
What's
it
stopping you? Losing marks. That's what's stopping you.
does it actually lose marks?
Yes, because you didn't actually fill in the graph. You just decided to draw like, what it screams is, I'm lazy, and my teacher taught me properly, but I'm lazy. That's what it screams.
Oh, it screams, I don't want to mess this up.
On our calculators, there's another separate line where we draw that on.
Yep, we just haven't done it yet. We keep going. So, because if we don't draw it, your screen looks like this, yours looks like this, you didn't draw the graph, right? There's two pieces. So we go second table, and we pull the rest of our values off. So we have -1, 1, -1, -1, sorry. And then we have 0, 0. And then we have an entire 6 hours to write our diploma. So why are we being lazy? Oh wait, did that come out of my mouth? And then we have 2 and 0.5. Enjoy your 6 hours, because you're never going to get that again. You're going to get tests in university that you can't finish. 0.6.
Nice.
0.6666. 0.7. 0.75. You also might get your calculator taken away, and then you have to use all your brain matter. Enjoy your calculator. 0.8. You might just get a basic one without a graphing function. 0.8. 0.83. And now, this would be me. This is good. But now I have to wing it. Do I wing it? No. I go second trace value. And then I go 0.75. That gets me, no. That's a lot. Second trace value. And I go -1.25. And it's fine. I'm just negative, sure. -1. -1.5 is -3. After that, I'm still sending it, or I would just do this, which is not enough graph. So I'm going to go second trace value, -1.75, and I get -7. And then that I can. Now, you can choose to not listen to me. You can choose to put 2 points. You can choose to wing it off your calculator. You can do all that, right? My job is to tell you what will get you full marks and what will not get you full marks. It's your job to choose which would you rather have. Would you want full marks or do you want no marks? These are your options. I can't force you on a test to do what I'm telling you you have to do. So it's on you. I see people on tests who still don't listen to me and still wing it. And then they get a 0. And it's, well, it's choices. Make choices. You probably get 0.5 out of 2 because you hopefully drew the asymptotes. But sometimes on a test, I get people winging the whole graph exactly how it looks on a TI-84, which has absolutely no asymptotes showing or a point of discontinuity. So you get no marks, not even 0.5. You have to show the dashed lines. I repeat, you have to show the dashed lines. Why do I repeat that? Because there's people on the test who do not. And I put my calculator does it. Cool. Listen to your calculator over me. It's fine. All right. Now, the x-intercept and y-intercept is 0, 0. My domain is going to be wrong most of the time on the test. When your domain and range involve a point of discontinuity, a lot of the time you guys will just tell me x can't equal the asymptotes. But remember, there's also an open dot on the other one. So let's look at this graph and explain why. So I have an open dot on -5, and I have a dashed line on -2. So the graph doesn't exist at -5 or -2, does it? So I have to put both of them. You guys will often put 1, because you won't look at the graph, and you'll just usually pick the dashed line. Or you'll look at your calculator, and it doesn't scream open dot on -5, right? So we have to look and say, okay, well, x doesn't exist here or here. So So x such that x can't equal -2 and -5. X and L are the reals. More often than not, people will get the domain right, but they won't get the range right because they don't know how to find the y of the asymptote, or of the point discontinuity. So they just don't put it and hope for the best. Y such that y can't equal 1 and 5/3. Y is now in the reals. B and C are for you. Try it out. Go.
That's exactly how I do it.
How many of these questions you?
I'm going to record. So we'll look at this one first, even if you're not done the other ones. So this one here, x minus 3, they're going to cancel off. So we're going to have a point of discontinuity at 3 and something, correct? The graph that's left over is x minus 4, x plus 3. Before I move on to asymptotes, I want to finish my point of discontinuity. I need to get the y for it. So I have x equals 3, and I need to plug it into this. So I get y equals 3 minus 4 over 3 plus 3, and y equals -1 over 6. So I get 3 and -1 over 6. And I always, when I do math, I always do it sequentially. I follow the same order so that I don't miss things. So the moment I find that point of discontinuity, if they want me to graph, I'm graphing it. So I don't forget to put it on there, because lots of people do. So 3 and -1, 6. Down here, and I make an open graph. Then I come back and I say this is my equation. My other MPV is x equals -3, so that's going to be my vertical asymptote. Because it didn't cancel off, it's an asymptote. I go up here and I say x equals -3. And then I sequentially follow along. I go to where x equals -3 and I say it's here. And I make myself a vertical asymptote. And then I have what's left over here. I have degree 1, degree 1. So I take the leading coefficients, which both happen to be 1 over 1 again. So I'm going to have a horizontal asymptote at y equals 1. And then I plug my original into my calculator. And I get -11 and 1.8.
I know, I was in a rush. I went to do hair this morning, realized there wasn't a good look, and this was the first hat I saw. Happened to also be the hat my daughter
Okay.
got on.
-11, 1.8. That's not -11. -11 and 1.8. -10 and 2. -9 and 2.1. 2.4. 2.75. 3.3. 4.5. -4 and 8. That one we can just extend because we're basically at the end. Then we go to the next one. -2 and -6. And I'm going to go -1.5. negative 2.5. 13. Oh, negative 2.2. One. Now you guys, you can go second trace value and just put in values. Like you don't have to go to the table of values. And if you just keep pressing X's, it'll give you a new X. You don't have to go second trace value, second trace value, second trace value. So I go second trace value and it shows up and I can put in -1 and it goes negative 2.5. And then I can go 0, enter, and it puts in negative 1.33. And then I can go 1, enter, and it gets me negative 0.75. 2, enter, negative 0.4. 3, enter, error. 4, enter, 0. 5, enter, 0.125. 6, 0.2. 7, 0.3. 8, 0.3. 9.4. 10. So you don't even have to use the table of values technically. You could just go second trace value, which I think is faster. And that's an open dot here. Error. Right? Your domain and range is just not those values. So sorry, what was the y-intercept? Negative 4/3. And the x-intercept, was it at 4? 4. And then here we get x such that x can't equal, sorry, this was x equals, or y equals 1. X can't equal negative 3 and 3, so plus or minus 3, x is on the rails. And then my y is y such that y can't equal 1 or negative a 6. This one, when we factor it, we get, is it 2x plus 1? I can't even remember. 2x plus 1? 2x minus 1, and then x plus 3, right? So my denominator completely cancels. I have a point of discontinuity at negative 3 and something. Now the catch here is, if your complete denominator cancels, you're just left with a line. 2x minus 1. Does a line have asymptotes? No. So these are not applicable. This is the best question, actually.
Oh, man.
And then we have to find the y that goes with negative 3. So we go y equals 2 times negative 3 minus 1. So y equals negative 7. So I'm at negative 3 and negative 7 open dot. 5, 6, 7. And then it's just a line, right? The line that was left over was 2x minus 1. So my y-intercept is at negative 1. And then my slope is 2 over 1. So I go up 2, right 1. Up 2, right 1, 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 right 1. And then technically I could go down 2, left 1, because I could pretend these were both negatives, right? Go complete opposite direction. 2, 1, 2, 1, 2, 1. Don't fill that one in. And if you know if it goes through your point of discontinuity, you're right. If it doesn't, you're either drawing the line wrong or your point of discontinuity is wrong. You're not going to just have an open dot somewhere off of the graph. And then my y-intercept is at 0 and negative 1, and my x-intercept is at a half 0. And then my domain is just the y, it can't equal, sorry, the x of the point of discontinuity, so negative 3. And my range is just the y of the point of discontinuity, can't equal that. So you have about 7 minutes I'm going to give you questions that you could finish in 7 minutes. So, page 452. Number 4, you don't have to graph it, you just have to answer all the things. And then 6. 6 is a matching question. 4 is 4 of these. You don't have to graph it. You take a picture of it off of here.